So in today's lesson we'll be looking at indices. Let's have a look at this question here. 3 squared, or 3 to the power of 2, times by 3 to the power of 4. Well, let's do this using the expanded notation method firstly. Our 3 squared, well, that just means 3 times by itself, doesn't it? So 3 times 3. Now we'll just put that in brackets to keep it separate from our next part of working. And we're going to times that by this 3 to the power of 4 here. So if we write that out in the expanded way, that's 3 times 3 times 3 times 3. So we'll put that in brackets as well. Now let's multiply that whole thing together. So obviously we're going to have our base number of 3, but how many 3's are being multiplied together? It's 6, isn't it? So that's going to give us 3 to the power of 6. Okay, well that's worked out our answer as an indice, but it's a fairly long way of doing it, isn't it? So let's see if we can work out a quicker way. If we look at our original question, you'll notice that both numbers have that 3 in them. Remember, that's called your base number. So we'll keep that base number the same. Now look at our powers here, 2 and 4. What could we do to them to give us a power of 6? Well, how about we add them together? So let's have a look at what we've got here. Our base number of 3, we'll write that down firstly. Now our power, 2 plus 4. Add them together and we end up with 3 to the power of 6. Well, look at that. Both methods gave us the same answer. They're both correct. I think you'll agree, though, the second method's a fair bit quicker, isn't it? So let's see if we can think of a quick way of remembering that. Well, the basic rule for indices is when we multiply, we add the indices. So let's have a look at some examples now, practicing using that rule. Number 1, we're told to simplify the following, leaving your answer in index form. Now for part A, we've got 5 to the power of 3 times 5 to the power of 6. So let's use our short method, our base number there, 5. We'll get that down firstly. Our powers, 3 and 6. What are we going to do with them again? We add the indices, don't we? 3 plus 6. So looking at that, we'll have 5 to the power of our 3 plus 6, which is 9. Now remember, we were asked to give our answer in index form here, so we leave our answer there as 5 to the power of 9. We don't have to evaluate that or work out our final answer. So 5 to the power of 3 times 5 to the power of 6 is equal to 5 to the power of 9. Now let's look at part B. 4 to the power of 7 times 4 to the power of 11. Well, have a look. What's our base first of all? There it is, our 4. Get that one down. Then our 2 powers, we'll add them together, 7 plus 11. So simplifying now, we'll get our base number of 4, and our power, 7 plus 11, will give us 4 to the power of 18. Well, let's have a look at part C now. 3 to the power of 5 times by 3. Well, this one's a bit different, isn't it? Look at our 3 there. What do we notice about that? It hasn't got any power, has it? What can we do there? Well, 3 by itself, it's actually got a power of 1. We don't write it, but we know that power's there. Now the question becomes really easy. Our base number, 3. Our powers 5 and 1. Let's add them together. So that'll give us 3 to the power of 6 as our final answer. Alright, let's get rid of these and we'll try a different example now. We've got 4 to the power of 5 and we're going to divide it by 4 squared, or 4 to the power of 2. So we're dividing here, just be careful of this. Now one part at a time, 4 to the power of 5. Well, that's just equal to 4 times 4 times 4 times 4 times 4, isn't it? Make sure there's 5 4's in there. Now instead of divide, what we're going to do is put that on the top of a fraction. And then on the bottom of our fraction we'll go our 4 squared. So that's just 4 times by itself. Now let's see if we can simplify or cancel out a bit with our fraction here. See, we've got those pair of 4's there. Well, they can both cancel. Then a second pair of 4's, they'll both cancel. Well, we've run out of things in the bottom of our fraction, haven't we? So we're just left with our 4 times 4 times 4 on the top. And what's that equal to as an indice? That's right, 4 to the power of 3, isn't it? Well, there we have it, our question's solved, but I think you'd agree, once again, it's a fairly long way to do it. Let's see if we can find a quicker way. Start off here, our base number of 4. What can we do with our two powers this time? Good guess. I think we try and subtract them, don't we? 5 minus 2. So looking at our answer there, 4 to the power of 5 minus 2, our base number 4. 5 minus 2 will give us a power of 3. Well, once again, both methods gave us the same answer. In this case, 4 to the power of 3. But I think you'll agree, once again, the second method, faster to use, isn't it? So our little rule to follow here, when we divide, we subtract the powers. So let's have a look at some examples here. Number 2, once again, we're told to simplify the following and leave our answer in index form. And in part A, we've got 7 to the power of 6 divided by 7 to the power of 3. Alright, so let's try and use our rule. Our base number 7, then our powers, we're going to subtract them or take them away this time. So 6 minus 3. So let's work that out. 7 to the power of 6 minus 3. Well, that'll just give us 7 to the power of 3. Now, once again, we're told to leave the answer in index form, so what are we going to do with that answer there? Absolutely nothing. Leave it exactly as is. We don't need to evaluate that one. Part B now. 5 to the power of 4 divided by 5. Well, we've done one like this before, haven't we? What do we do with that 5 there, where it's got no power? Yep, we know it's got a power of 1, don't we? So we'll write that in there. Makes the question heaps easier. So our base number, that's our 5. Then our powers, we'll do 4 minus 1. So working this out, 5 to the power of 4 minus 1 gives us 5 to the power of 3. Alright, let's get rid of these ones again and we'll try one more example. 7 to the power of 3 divided by 7 to the power of 3. Well, that's pretty similar to the last ones, isn't it? So let's try it using the same method as for our division. We'll start off here, 7 to the power of 3. We know that's 7 times 7 times 7. Then for our division sign, we'll put that on the top of a fraction. And then on the bottom, for our 7 to the power of 3, we'll get the same thing, 7 times 7 times 7. Right, pair of 7s, cross them out. Another pair of 7s, cross them out. Another pair of 7s, cross them out. Well, what have we got here? Everything's gone. What does that mean our answer is? Do we get 0 for an answer? No, we don't, do we? Very common mistake, that one. Be really careful of this. In this case, where the whole top of the fraction cancelled out and the whole bottom of the fraction cancelled out, it means we've got the same thing on the top and bottom. So we're dividing one number by itself. Now, anytime you divide a number by itself, what's your answer? It's 1, isn't it? So in this case, our answer is equal to 1. All right, let's try it using the short method. Our base number there, 7. Our two powers, we're going to subtract them, 3 minus 3. So let's work this out. 7 to the power of 3 minus 3. We'll take away those powers and we get 7 to the power of 0. Oh dear, what's happened here? 7 to the power of 0 using the short method and 1 using the expanded method. Does that mean we've found a problem with our rule? No, it doesn't. In actual fact, what it means is that anything to the power of 0 equals 1. So any number or any algebraic term, if we raise it to a power of 0, we'll get an answer of 1. All right, let's have a look at some examples of this then. We're told to simplify the following. So part A, we've got 3 to the power of 5 divided by 3 to the power of 5. Well, let's go through it. Our base number there, 3. We'll take away our two powers, 5 minus 5. Now, if we work that out, 3 to the power of 5 minus 5, well, that gives us 3 to the power of 0, doesn't it? But we're not going to stop there, because what do we know about that 3 to the power of 0? Well, we know it's equal to 1, don't we? So let's make sure we finish that one off. Part B now, 8 to the power of 0. Well, this one's quite easy, isn't it? 8 to the power of 0, well, that's anything to the power of 0, so once again equal to 1. All right, part C, 2 times 3 to the power of 0. Well, is that equal to 1 as well? Well, no, it's not. Because if we look here, it's only the 3 that's got a power of 0. So that means that that part of our question, our 3 to the power of 0, That's equal to 1. Now, because our BidMath says do indices before multiplying, we'll write that down. Now our question becomes a bit simpler. We've got 2 times 1. Well, I'm pretty sure you can do that one in your head, can't you? 2 times 1 equal to 2. Well, there ends our question. Not just our question, though, that ends our lesson on indices. Well done working your way through them, and all the best now working your way through the questions.